Hmm. Okay. Is it good? Is it stable? Sometimes it's not. Sometimes it does. But I hope it's okay for you guys. Hmm. Okay. So I believe we can go live right now. Because whatever. But also at the same time, I'm apologize that we are slightly a little bit late of the schedule. From the schedule because for a little bit whatever reason behind the scene. For example, I just updated my OBS studio, and also because I want to confirm that Rocket Lab will actually going to stream live. But I guess we are good. We can go right now. So let's see, and let's go. All right. So is it okay? So hello everybody. This is my good morning trademark. Okay. So hello everybody. This is Daniel Suguwa, and good morning from Sarawak. From Borneo right now. It's morning here, and especially from the lounges that we are going to see right now from New Zealand. They're right now already in the already in afternoon, evening, something like that. But it should be fine. It should be fine. And yeah, I guess we for today. This is my 58th live stream. Wow, well, a long shot to go. Okay, and we are going to watch the launch of the Rocket Lab's Electron rocket, where it will carry the Japan Aerospace Exploration Agencies of the race for satellite, but not the typical race for this one. It would be the considered as the part one of two for this race for mission. This one will specifically carry the D dash cell spacecraft, which will also going to test and try out everything else that's needed in between all of this. So yeah, so that's why we are going to watch these two. This one will be the part one, and the part two will for the rest of the CubeSat would be by quarter one of 2026, which will be ranging around from January to from January to March 2026. So we are going to watch that too, if the timing is all right. But even if I can't go to the stream for whatever reason, could be because of my class, or maybe because I'm not available around that time, it's still fine, and it's still okay. We are still going to go and watch it regardless. So at least we have this stream right now, so the mission will be almost identical, and it's going to go around 540 kilometers with the inclination of 97.5 degrees. uh, essentially this is the same orbit. If you want to go to the sun synchronous orbit, where you really need that constant sunlight to do some Earth observation, whatnot. But in this case, this is mostly for consistency. So JAXA can keeps how do I say it? So JAXA can keep itself in the telemetry, in the line of sight with LOS, with the nothing to do with the loss of signal. This is more like LOS of line of sight with the satellite constantly. So that's why they chose for this sun synchronous orbit. So that's why. And yeah, because it's sun synchronous orbit, it's obviously going to be circular orbit. I mean, barring some few small variation and deviation, especially also due to the uh, due to this current if I remember, this is a solar cycle 36 or 26, something around like that, where usually sun flare is right now. It's basically at its max pain. There's like constant sun flare, constantly bombarding bombarding us to us here on Earth, and also to the other places. For example, if it's heading to the to the Jupiter, it might also go into there at the same time. So it's not only just us; it's also to the other different planet that also feels the same thing as us. So barring that all of you, unfortunately, can be compensated with the thruster, yeah, with the satellite's onboard thruster, so it still can propel itself to upward. So that's that. And let's go to this stream. All right, let's go to this stream. And yeah, we are. I'm not going to cover that much. Okay, they are still going for the call out. I'm not going to open sound for now because we can cover a little bit. Okay, and this is what I will going to show you. Okay, this is pretty brief. Don't worry about. Oh, sorry. This is a little bit brief. Don't worry about this. Okay, and here is this. This is the press kit for the for this launch. This one is specifically for the this one press kit from the Rocket Lab for their own Electron rocket launcher here, or orbital launcher. So you can see this is the mission patch. Okay, and yeah, that's a little bit of slower down for me. Don't worry, that's how I operate sometimes. Most of the time. Okay, and this is the orbit, like I said, 540 kilometers, literally almost circular, or aka circular, but in real life it's almost as bad as it can get. And obviously it's going to be one satellite, RAISE-4. In the specific cases, it's going to be a D-cell satellite, because, well, they have to spread this out into the two parts. And of course, this is the JAXA's first launches onboard the Electron rocket. So in this case, JAXA right now just ended up just going to this dedicated mission to this Electron rocket. I mean, like to this Electron rocket lab, something like that. Yeah, and also of course, it's not the first time that JAXA did this too. Few of it, but this one is specifically, I can say, quite notable in recent memory. So that's why I also want to show this. I mean, yeah. Fortunately, these Electron rockets are not launched as frequently as Falcon 9, so I didn't get tired with Electron rocket for now. And yeah, I do need to admit, I'm a bit tired of Falcon 9 rocket launches. I mean, sure, it's cool to see it lands, launch, and whatnot, but once it became way too routine and usual, it can be a bit boring at times. So sometimes that's also the reason why I don't stream Starlink. Yeah, even if I stream Starlink, I just only stream it because, let's say, maybe periodically need to refresh, or for example, if that's Starlink for that particular launch, I didn't stream it yet, I will stream, but the rest of it I will not stream, like 99.9% of all time, maybe just barring only like 0.01% like that, unless they're going with the full fat V3 version or something like that. Yeah, but anyways, let's go back to this stuff. Let's not diverge ourselves from that topic. Okay, and of course this is going to be launched on the Rocket Lab's Launch Complex 1B. Okay, just this one is like the second newest after the original launch pad on the Pad A. Pad A is basically heading to the sea, while the Pad B, it's slightly on the right side. If you get what I mean, because how do I say? It's hard for me to try to animate this stuff without anything particularly in my hand. So yeah, and this is how it looks like. Okay, Okay, and looks like there are also okay, and as usual, it's going to be separated using the motorized light band, basically the Rocket Lab's proprietary uh, payload adapter here. It will be deployed using this, and we are not going to go too long, and there's a little bit of symbolism what does all of this mean. And this is the RAISE-4 satellite. Okay, what the star symbolizing the single JAXA satellite deployed to during this mission, and this is the Electron rocket. Obviously, you know this koi fish, basically representing one half of harmony, and the koi fish also embodies balance and perseverance, which is the central themes of these missions visions, and also Japanese kanji for change. How do I'm not 100% sure how to pronounce it, but uh, let's go. Highlighting it says here that it highlights and the transformative nature of the mission and its role in advancing aerospace innovation. So yeah, and you can see this one. If I zoom a little bit closer, if you actually actually put this mission side by side on this mission right now, Rise and Shine, and also Kakushin Rising, which will be by next year, you can see this is essentially quite a mirror of it. And yeah, you can see there's also 1, 2, 3. Okay, there's 8. So the rest of 8 CubeSat will be launched on the next year. So that's that. That's why. That's why I said we are go. This is considered as the part 1 mission of the RAISE-4 space mission, and yeah, this is the launch event, but we are not going to go too deep here because the time is not really on our side, and also obviously because I have to delay to go stream for like by almost 10 minutes or 10 plus minutes due to the technical problem on my side. Yeah, not I mean, even this laptop really, I really need to change the laptop sooner or later. But if I do change, you might see why. Okay, but I will inform later if I did. Okay, so here is the press kit, but this one is the translated from Japanese. So here we go. We are going to see the main mission here, the D cell. Yeah, this one, the rest you see Liomi, Gemini, or Gemini, Kir-X, TDS-PPT, Helios-R, CF-Cam, and Iris, if I have to pronounce using native pronunciation. These seven of these is like a payload integrated inside the D cell, just like try imagine like if you're trying to put everything inside the APU, right? The accelerated processing unit. You tries to integrate memory caches. You try to put out with the, let's say maybe you want to put GPU, CPU, and also because why not, people would just going to say, oh, just put NPU for AI acceleration, whatever is it. It's kind of like that. It's integrated into one, and all of this integrated into this D cell, just like analogy I'm using based on my my specialty in computer science, mostly as a computer science student. So that's how I try to use this analogy in some way. Okay, and looks like we are less than 3 minutes before launch, or if we are a little bit lucky, maybe we can go. Okay, so this is this one here, and another one. I'm not going to go deep dive too much, but you know, this is the RAISE-4 satellite, aka separately known as the D cell. Okay, so as usual, there's going to be a low Earth orbit satellite, the MIMO. If I remember, MIMO stands for multi-in, multi-out, multi-input, multi-output / IoT, Internet of Things, transmission equipment, LIOMI. This one is for the, I believe, for the transmission. They want to try to prioritize more on the low power consumption side, because remember, even though you have a lots of sunlight and whatnot, but anything can happen with the payload. So sometimes having a low power solution is good. Okay, and also there's going to be consumer GPU demonstrator Gemini, just just to do some processing power inside it, to process any kind of data. So consider RAISE-4 is more like a technology demonstration satellite here, and also it's going to have integrated with the X ultra compact integrated propulsion system, which will use water as a propellant. I mean, like, for quite some time, I'm actually still studying about this kind of stuff. If you can make this one, this will be one of the best monopropellant rocket you can use. Okay, and high efficient and also, but also at the same time, it's a little bit of challenging because you need to electrolyze, right? You need to you need to put some small kind of storage to put in hydrogen and also oxygen, so it can be burnt together. So it's a little bit of challenging, but not impossible. There's also going to be pulse plasma thruster for small satellites, TDS-PPT. There's obviously going to be D-cell membrane deployed deorbit mechanism, Helios-R, lightweight deployable structure with power generation and antenna functions, radiation resistant Earth observation, color camera CF-CAM, and also SOOI SOC powered onboard AI object detection system Iris. So that's that. And how the deployment would look like, it will be like this. Yeah, like this, Helios-R/diesel. So that's that. We are going to go with the live. Let's go, everybody. Enjoy.
Stage 1 and Stage 2 tanks are pressure.
Yeah, so that's basically a bit of record how I tried it. And also at the same time, from the live chat, previously before it goes live, like few days ago, there's comment from this user at SKRIS hash 3yo yo or Skirish Heyo. Squeeze Heyo, I believe. All of these capital letter and also number. Rise and smell the ashes. Yeah, I agree. Rise and smell the ashes. But at least it's going to be to go up to the ashes. So as a burning phoenix. So okay, and 5, 4, 3, 2, 1, ignition. All 9 Rutherford rocket engines ignition and liftoff from the new from Rocket Lab's launch complex 1B. We have liftoff from the New Zealand, from Mahia Peninsula, and looks like the rocket is going pretty good. And here we go from the Canberra, from the faraway Canberra range, and also this is from the tracking camera. Okay, looks good, and it looks like already focused on the rocket engines itself, and also from the flame, and also faraway Canberra. Yeah.
With JAXA's RAISE-4 mission. Next, we'll be listening in for confirmation that Electron has passed through max.
Okay, by now it's already going more than Mach 0.5, so obviously it's going. Obviously, the rocket engines will be throttled down to 60% before it finally breaks the max Q, the maximum aerodynamic pressure, fully exert on the launch vehicle. Okay, approaching, getting ready, on my mark. Okay, Mark, we've already cleared the max Q for the Electron rockets, and by now the route. Okay, so now Rutherford, all 9 Rutherford sea level rocket engines is now throttled back up to 100%. And yeah, because the reason why it needs to be throttled down to 60% before it's around the Mach 0.5, aka the halfway to the speed of sound, until already reach the max Q, is that because you need to remember, at least from what my understanding is that the structural load that will be exerted against the launch vehicle it's going to be proportionally very, very, very high, especially going to the certain velocity, certain speed of the launch vehicle of the rocket itself, according to the
Engine burn detect
thickness, according to the
15 seconds.
atmospheric pressure and also density. When all of these combine together, it can exerts very, very max pain
Confirmed.
of the rockets that will cause pain and whatnot, whatever is it. And interstage separation, and second stage already ignite for the Rutherford vacuum rocket engines
As you
there.
just heard, that's MECO stage
After
separation,
the
and second
MECO,
stage
after the
ignition
main engine
confirmed
cut off
successfully
on
by
the first
mission
stage.
control.
Yeah.
Next up, we can expect fairing jettison.
Okay, and
With
getting
only
ready
one
for
inside
the
fairing,
firing
we
jettison.
should get a pretty good
Von
view of
Karman
Raise
already
4
passed.
being exposed to space for the
Von
very
Karman
first
line
time.
already passed there, and getting ready for the pilot frame separation. Okay, here we go, and we have pilot fairing separation.
Jettison confirmed, and that's Raise
There's
4
it. Pilot
underway
firing
now as
jettison
Electron
already
begins
confirmed,
its
and it's
mission to
already
orbit. We have a few minutes
already
between
detached
now
from
and
the
our
rockets
next
that
milestone for Electron.
already
The battery
detached
hot swap from stage 2
from the
rocket
NOSCON
engines.
side,
For
because
now,
obviously
Electron is
it's no
performing
longer
nominally, traveling at a
no
velocity
longer
of
needed to be
8,500
to
kilometers
protect
per
the satellite
hour,
from
and
the
currently at more than 133
atmospheric
kilometers
pressure,
above
from
Earth.
the atmospheric densities, whatever inside the Earth's atmospheric. That one is no longer needed, so of course it's going to be separated, and also to keep the rockets itself lightweight. And of course, what you are hearing right now, that one is actually the onboard microphone sound from the second stage. That's why you can hear this second stage one. Okay, and of course, contrary to most what people actually says about this, about space itself, it's not 100% vacuum. It's more like maybe something like 98% of vacuum. So of course, as long there is some sound, and of course as long there is some pressure, there's also a little bit of something maybe burns in between. You still technically can hear it, but I believe this camera, I believe that the microphone should maybe already tuned down to actually hear this sensitive sound. Usually it's going to be pretty faint if you
When that
hear this
swap
in
takes
real life,
place,
but
the old
of
battery
course,
packs are removed
that's how
and
it
pulled away
functions
from the
on the
rocket. The silver
launch
pack on the
here.
right-hand side of the screen will be the one
Okay,
to watch during
and
airlift. When the
so
hot
I
swap
believe
occurs, it
I
will
should also
disconnect
go.
immediately, and you should see it fall away out of frame.
Okay.
At T plus
And
5
yes,
minutes on the clock,
and the
you've got
reflection
about
you're
60
seeing
seconds
right
left
now,
until
this
that
one is
milestone.
real. This one is not, it's not some video games that you saw back around 2000s, or maybe 90s, 2010s, or even the current generation right now of the rasterization and even ray tracing. It's not like that. This one is real.
Guidance nominal. 200 seconds.
So that's why it's a bit interesting to look at this. And okay, and after that we are also going to see the battery jettison, which, if I remember correctly, out of these two, all four new battery packs, two would sorry,
roughly 30 seconds.
okay, around 30 seconds before battery jettison. All of these four battery packs, the two that currently in use will be jettisoned, and but at the same time, simultaneously, the new battery pack will be used on the other unused two one, because you need to remember, even though all of these rocket engines uses the electric pump fed, which basically the propellant will be moved by. Okay, and you can see the battery jettison has already confirmed, and now hot swap has already successful, and it's still alive.
Nice,
And
a clean hot swap by
yeah,
Electron. The
and
second
you need to
stage is
remember
carrying
that
on beautifully, carrying
that because
Raise
it
4 to
uses the
orbit.
electric
Stage
pump
2 is
pump
now
fed
traveling at 16,000 kilometers per hour
mechanisms
and performing
of these
nominally
rocket
as it
engines,
heads toward
usually
our
it's going to be
540
either
kilometer
full
altitude
flow
target.
stage
Between battery
full
hot swap
flow
and
stage
Seco is another
combustion,
2.5
or maybe
minutes of
even
burn
some
time
stage
until the
combustion
second stage
side,
Rutherford engine
maybe even
produces up to
open cycle, aka
5,800
the
pounds
gas
of
generator
thrust in a
one.
vacuum of space.
And
Electron's second stage is
what on
located almost
what on
along
in
this
between
stage of
all of
entry
this?
during this phase of
This one
flight.
uses the
And all that's
electric
left to
pump fed
complete now is engine shutdown and
electric
separation,
pump fed
which will be a
engines,
very
okay?
similar process to what we saw earlier
And
in the
instead
model
of
for the
using
first
the
and
turbo
second
pump,
stages.
it's going, of course, it's going to use the I believe DC motor. DC motor, yeah, it's going to use the DC motor brush there to uh, some kind of size to move those propellant with lots of pressure going down to the combustion chamber. And of course some of it also being used to cool down the cooling, being used to move it to the cooling jacket to cool down this rocket engine, so it's not going to melt by itself. So that's why the batteries has like 4 packs here instead of like nothing
We're
at all.
coming up now on the final actions for the
And
second stage.
and of course you need to
Very
remember
soon, we're
that
going to see the Rutherford engine power down and shut off completely for our SECO maneuver.
and
or
and of
setting
course you
engine
need to
cutoff
remember
on the
that
second stage.
that because
Once the second
because
stage of flight
technically
is
the
complete,
battery
the kick stage,
energy,
JAXA's
if I
RAISE-4
remember,
spacecraft
energy
attachment,
density
will be
is not as
separated into
great
staging
as
order
like
ahead of payload deployment.
kerosene,
SECO is
as
scheduled
like
to take place
any
just
of
a
these
couple of seconds after T plus
any
9
of these
minutes.
turbo
Not long
pump
to go
power,
now.
okay, where it can be powered up just by only burning the propellants. Of course, that's why the battery has to be jettisoned and whatnot. Okay, and looks like pretty interesting on
terminal,
the
20 seconds remaining.
up there. Okay, and looks like 20 seconds remaining, and the orbital velocity should be around 27,000 plus kilometers per hour. Altitude right now is should be good, 203 kilometers, and getting ready for the second second engine cut off, the SECO. Let's hear the
Okay, confirmed.
okay.
Nominal
We've
transfer
already
orbit
heard the
achieved.
call out, and nominal
Stage
orbit
generation.
has already achieved, and now s- um and now interstage separation and the kick stage, the
Great job
QV,
by Electron. That's
has right
shutdown of the
now
vacuum Rutherford
going
engine and
going into the
separation of the kick
ballistic
stage
cosphrates
confirmed for the
mission.
Raise and Shine mission.
In this case,
RAISE-4 is
the
now
rocket
traveling on an
engines
elliptical path around Earth
on
with a perigee
the
of
upper stage will not be
188
ignited for
kilometers
quite some
on
times
its way
until
to an apogee
around,
of
I believe, 40
540
plus
kilometers.
minutes,
In the
something
final
from
moments
now.
before payload
So
deployment, once we reach
so that's
that
why
apogee, the kick stage will
so
fire up its
so
very
that's why
engine
it's need
to
to
kick us into a circular
so
orbit.
that's why it needs
Hence
to
the name
be
kick stage.
yeah.
Now that's scheduled
So
to
that's
take
why
place around T plus 51 minutes into the
okay,
mission.
T plus
So we're going to take a
41
break on
minutes
the broadcast now
or
until
51.
engine startup begins.
I heard it.
We'll leave you with this graphical representation of where the kick stage is above Earth. And if we're above your country, jump outside and give RAISE-4 a wave. Otherwise, we'll see you back here for deployment in around 40 minutes or so.
Yeah. Okay. Did I hear it correctly? 51 or 41? Which one is it? Oh yeah, 51 minutes. They will be coming back, but specifically from what I read, is that later we are going to revisit this again. So this is the graphics representation. So we still should have time on around 40 minutes from now before they are going live again, and maybe probably I'll be taking a little bit of rest from talking because too much things to talk, lots of interesting things here and there. Okay, so speaking about which, I need yeah, what I want to say, because the in terms of the energy density of the electric pump fed, I mean of energy density of the battery that they are used in the electric pump fed engine. In this case, usually it has a little bit, not a little bit, it's like few times lower than the energy density of, let's say for example, maybe even a kerosene. So that's why battery usually have, they need to pack in another spare battery just in that, just so they are able to swap it pretty nicely. So that's why. And of course it's already going already out of range right now. LOS, the loss of signal, nothing to do with the earlier terminology of the line of sight. This now is loss of signal. Okay, and also it's around the Antarctic Antarctic area, around the Antarctica area. If I have to be, if I have to use this buff word, because why not? In also in Malay and English. So that's that. It's already going out of the range, and shall be see soon around, probably maybe 5 or 8 minutes before the acquisition signal order being carried out. So that's it. And also, what I'm going to say here, maybe I can comment a little bit. Okay. Okay. Mhm. Yeah, I guess I guess this should be a little bit humorous comment, but nothing mean to the to JAXA and whatnot. It's just like some cool cool remark here. Okay, so maybe I can put something. Huh. All right. So why not? We just put like this. Yeah. So in case you want to know what comment that I referred to, because you might not see this on the stream, I'll try give you guys a screenshot before I actually go live. So wait, where is it? Where is it? Oh yeah. Oh yeah. Okay, so why not I'll do this. So I'll do this. Okay, this is what I able to screenshot before I go live. Yeah, this comment actually a few days ago. So literally this is what I mentioned here. Okay. Here, rise and smell the ashes. Comment by this Squeeze Heyo. Yeah. So this is my response. so yeah. Rise as a phoenix and smell the ashes. Smell the glorious ashes. So that's that. I mean, also it's kind of appropriate when you think about it, because you want to know something, why? Because look at this. Back when JAXA actually launched the RAISE-3 missions on board the Epsilon rocket, the mission unfortunately not successful enough. It's pretty, how do I say, not really good as far as I can tell. So that's why. And that's why if this mission's actually really successful, even the part 2, it's going to be exactly that. So that's why. And yeah, and looks like, because I don't have much else thing to do and I want to know what's up with the drop frames. It's like constantly drop. Sometimes it's there, sometimes it's not. I don't know. It's probably just like my cellular internet just screwing up itself. I'm not 100% sure, but regardless, if you're still sticking here despite these enormous drop frames, I hope you're still able to stick around. And I'm very apologize that this thing actually happens. Yeah, it should not happen, but whatever cellular internet, that's basically out of my reach at this point. I tried moving in between this table. I'll try. I've already tried it. It's just it is what it is. Okay, I cannot control on my that on my side anymore. So that's that. And I think I should take a little bit of rest, or maybe I can try give you guys the something else. Yeah, why not? I'll just explain a little bit what we are also going to do next. On T plus 51 minutes and 43 seconds, the kick stage QV engine will ignite, and then later on around 2 minutes and 11 seconds after that, at T plus 53 minutes and 54 seconds, kick stage QV engine will cut off, and then also, which will be followed by less than a minute, around 50 seconds plus minus, barring the condition of the separation for the satellite separation. The payload deployment will occur for the RAISE-4 satellite there. So that's what I can read from the press kit, and I don't think I need to do that long. I will also try to cover on the press kit translated. Maybe why not? We are also going to look at the press kit by the JAXA again while we are still waiting, before I'll take a little bit of short break here. Okay, so I believe this should be good. Hello, there must be some. Oh yeah, here we go. This is what I'm looking for. Okay, so yeah, so like this one. Okay, so this is how the missions actually looks like here. Yeah, actually this picture-in-picture feature is actually pretty useful. You should try it at some point. Okay, so this one, let's go back on the translated press kit made by translated press kit, albeit mostly a machine translated, contributed by the NASA Spaceflight for a member. Okay, here you can see the mission and features of the small demonstration satellite number 4 here in the RAISE-4, aka known as the Rapid Innovative Payload Demonstration Satellite 4. So here we can see the mission and features, and yeah, as usual, this is a technology demonstration mission to demonstrate all of the 8 payload in orbit as the demonstration for the whatever is it under for the proposals under the JAXA's Innovation Satellite Technology Demonstration Program. And yeah, it's also in response to whatever is it to demonstrate the core's space system components, and also new things. New things that will be integrated on the next future satellite, on bigger satellite next time they try to build this. And of course, this one is a pretty this one will rapidly build and also low cost at the same time. So, and of course, it needs to be reliable, robust, and whatever is it. So they need to achieve these two short that can be built low cost, rapidly, and also another one that I want to say, actually 3, and also rapid and also reliable at the same times. So they basically developed this in the short span of 2 years. So apparently, and yeah, if I remember about the RAISE-3 mission, that one were originally launched on, if I remember, October 2022. Yeah, but due to the third stage wrong orientation wrong orientation programs, and another few things what happens on the third stage, the satellite instead were deployed in a wrong orbital velocities, and also wrong inclination. So unfortunately, it was a loss on the Raise 3 mission. So Raise 4 is basically like the second redemption. And also, what do we call this? And also we call this as the we call this as the reflight. Let's just call this more like the Raise-3R mission, sort of like that. If we want to call, similar to how 3Com originally were lost on the SS 520-3 mission, which were reflown on the SS 500-4. That one till this day is the smallest orbital rocket that till this day built around the world, which were launched as the 3Com-R. So basically, we call this. I like to call this as the Raise-3R mission as well. But Raise-4 is also okay. Okay, and also there in this development, they also actually introduced this one engineering principle called as the model-based system engineering, because so it can improve efficiency through the digital development in satellite development. And let's say if it all goes well, and from what they can learn, they will apply this on the next few missions. And for now, it's still in trial use in environmental construction, model creation, design, traceability, and review boards. And they will apply this a lot across all of their JAXA's industry, in the space industry in Japan in the future. So that's why they are doing that. And this is the main satellite system configuration. Whatever inside it, it has like core functions of satellite system, such as data handling of telemetry and commands, satellite management, mission data processing, and most of these functions were done by the onboard computer, basically done in autonomous way in some sense also. And yeah, the communication system will going to use the S-band and also X-band. The S-band mainly to control the satellite, and the X-band just to downlink all of the experimental data that being used, because of course X-band is also pretty useful. The problem is that it's in terms of frequency range, it's only higher side that it could actually blocks the view. It could even just a slightly a little bit more obstruction. It means all of the data cannot be used, and controlling the satellite would be a lot more harder. So that's why they use S-band, because S-band at least it can penetrate a little bit of the, how do I say, it can penetrate a bit of a bit of the obstruction, so they still can control the satellite despite the obstruction and the satellite around the line of sight, something like that. Yeah. And also the power system, they, as usual, they will have each of the power subsystem, whatever is it, they have solar panels, and they have, and as usual, it has batteries, specifically lithium-ion batteries. But maybe in the future it could also change. If, say, for example, if sun, not sun, what? Because I mistaken this with sun synchronous orbit, whatever is it, but but maybe in the future, if the solid state batteries end up getting better, and maybe even have slightly higher power energy density. Yeah, sorry, because power and energy, these two are two different things, but we usually will confuse anyways. So that's why. So batteries as usual to store the power whenever to charge it and whatnot, and especially if it's going through the night time of around the Earth. So that's why. And also the SCS, the altitude control system, It's of course going to use a 3-axis altitude control system. It can use to change maneuver functions and also perform altitude controls, require for whatever is it. Could be for satellite operations, could be for the experiments, whatever is it. And also it does have redundancy in case it fails. There's also another ACS device that can be used to control it in case anything happens. And this is how it looks like. This one is Helios-R deployment form. This one, I believe, without this cell. Yeah, that this one actually without the cell deploy, without the D dash cell. And let's say, for example, if it's going to test out for the deorbit function, they can use this one, D cell. This one will essentially using a combination of the Earth's atmospheric drag and also the solar flare, solar flare, or maybe more like the solar photon, photon, whatever, how many photons out there. It uses this to combination to slowly deorbit it to back to the Earth. But sometimes some mission, from what I can tell previously, also some of it are pretty smart as well. They can the solar cell propulsion itself, they technically can also use, like, for example, they can use it for multi-purpose. For example, could be for to deorbit or raising up the orbit. Also technically can works as well in the mission. And yeah, this is how the specification looks like. Okay. And here it says that local solar time passing the descending node. And this one, I believe, the Japan standard time, around 3:30 p.m. Okay, I believe maybe 3:30 p.m. they will be able to acquire the data, or maybe around 3:39 between these two, barring plus minus. Okay, and also the dimension itself is around. Okay, let me translate this properly. It's around 790 millimeter by 1000 millimeter by 10 millimeters. So yeah, and also it says here, not the satellite separation section and deployment items not included. So essentially that, and the total mass of this satellite is 110 kilograms, and also I believe should be fully loaded by then. And yeah, we've already covered this. Postural stability, I'm not going to pretend to know this, but it should be around less than 0.1 degrees per second. Okay, and also altitude control, it has something. Usually the average during the sunshine, it says here that BOL is more than 215 watt and EOL is more than 180 watt. And it says here that postural stability, aka how much stability it can actually use even despite less than usual sunshine, would be the BOL would be more than 105 watt hour, and also EOL is more than 62 watt hour. Yeah, so basically, you want to know something, when we say the watt, actually it refers to the watt per hour. That one is already precisely can be used for power generation, not energy density. So this one is for power, not energy. So that's why there's two differences in between there. But we use this watt nomenclature nowadays because, well, even you and I knows average thing about this one. So that's why. And also the mission periods, it's going to be around 15 months, aka 1 year and 1 month. So for the first 2 months, it will be used to calibrate, to test the satellite whatsoever, before finally finally go in operation, um, before finally go for the operation for 1 year and 1 month. Yeah. So sorry. It's when I said that. Sorry. The total mission period will actually be 1 year and 3 months. Okay. I'm sorry. That's a little bit of my brain fart hiccup moment. Very sorry. Okay. So this is the diagram how it looks like. And yeah, I need to remind you guys, if you want to know more about this, you can actually go to the JAXA website, whatever sources is it, or the easiest one, if you know Japanese, or if someone out there already translate Clear Usu's explanation, you can also refer to Clear Usui, because you need to remember Clear Usui is at I can say has a lot of closer connection to the to JAXA, okay, to the government to the Japanese space government agency, more so than myself and literally everyone else out there. So if you want, you might as well just ask or even watch Clear Usui and also JAXA as well. You might as well do that if you want to know. But this is what I know from the press kit here. Okay, the same dimension, same weight, mass, and this is what I mean here. Here, Iris here, the onboard AI object detection using SOC. Okay, but yeah, I'm not really super duper familiar with this word because even though there's courses where we are learning about the artificial intelligence, the AI, yeah, despite how many AI hype out there, but because I'm computer science student, why not? They we have to learn this. So, but so far from what I learned in my courses, I'm not familiar with this this word yet. Maybe this is something not even my course cover so far, but it's okay. I'll go and search this later. and also number 7 here is the CF cam, the radiation resistant Earth observation color camera, aka just stuff something that you see in real life, one by one. Okay. And number 1 here, Liomi, low Earth orbit satellite, MIMO, multiple input, multiple out / IoT, Internet of Technology, Internet of Things transmission equipment. And number 4 here is the TDS-PPT, pulsed plasma thruster for small satellites. Okay, that one is actually pretty interesting. I know the reason why they actually go with the idea. This one, they are essentially using the pulse jet. If I remember, like the pulse jet technologies, something that's already being established even back then around World War II, or even before World War II. It's already being studied about the pulse propulsion technology in general, but up until recently, the space industry is finally already take note this pulse propulsion technology. It's pretty interesting how they are also currently researching this one. Yeah, I mean, I'm also interested if I can build the rockets, I can build the satellite itself. I also wants to actually research this one. If I remember correctly, this one is using the water-based propulsion, where it should be electrolysis out from the typical water, the H2O, to the 2 parts of hydrogen and 1 part of oxygen. And then when you burn it back together, it will become water again. But it's also can be super hot at the same time. But I believe maybe the reason that why they might actually use it, they are going with the pulse propulsion technology at the same time, is that to also sort of overcoming the problem, not only with the oscillation problem, complexities and whatnot, but also probably another reason, my speculation is that because of the cooling reason, you know, because trying to burn this trying to burn hydrogen to turn it into a nothing more than actual water. I mean, literally literally like no molecule losses to not make it as a water. Okay, it became 100% water. That one requires tremendous amount of energy. Let alone even when you try to burn this, it will be super duper hot. So I believe that pulse propulsion technology will use here also to overcome the cooling side problem here. So that's why. But yeah, I hope JAXA actually successful on this one, because if they're successful, it will be very very good for the space industry in general too. And yeah, and to be honest, maybe this is something I will try. Uh, I can say I'm still trying to learn this, but also at the same time, it's also particularly in my very very high research interest. Even though I'm a computer science student, but well, everyone's that's basically amateur in this stuff. Well, they have to start somewhere else. It doesn't mean it's impossible, just that if you're not in the aerospace specialization in general, of course you have to figure out smartly how they implement this stuff. Okay, using nothing more than probably self-learning, whatever is it. But but other than that, that's all. I'm not going to say too much. This one is also partly one of the interests. So I'm looking this pulse propulsion technologies with high interest. That's all I'm going to say. Yeah, if I try to build, I might try to build some of this thruster, but whether or not it will be on the work, well, I cannot say further. That's all. Sorry, I'm not going to say anything further. How is it until we are ready, in case. But anyways, let's go something else. Okay, this one, the number 3 here, the Kir-X, a water-based ultra compact integrated propulsion system. This one I believe is the okay. So this one is the plasma thruster. Wow, what a. But also at the same time I got confused a bit because water propulsion. But I'm not surprised if this also has anything related between these two. But plasma thruster, if from what I can tell, could also be something to do with the solenoid, whatever is it, resistor jet, arc jet, what I'm going to say. I'm not going to try. I'm not going to try to cover this one, but well, because of my confusion, I ended up maybe this is the best idea. Maybe I can try study these two together and try to how do I say, try to mesh this up together in case that happens. But until then, whenever it's going to debut, I don't know. The orbit mechanism also, technically, if they repurpose this in some shape or form, technically also can be used to raise the orbit as well. And also Gemini, the consumer GPU demonstration machine. Oh, sorry. Sorry. I'm very. My apologize. Okay, this is the consumer. Inside there's going to be consumer GPU demonstration machine, which were internally installed inside the satellite here. And also Helios-R, the lightweight membrane deployable structure with power generation and antenna function. Also interesting, because it's almost resemble the diesel, so you can be confused between these two, just like how I also confused the pulsed plasma thruster and also water propulsion system. Yeah, wow, there is a bit of overlap that will makes me confused. Yeah, but well, this is JAXA. They're pretty professional with what they're doing. Okay, and this one here is how it looks like for the Leomi, and for this Leomi, because of course this is the MIMO slash IoT technologies. MIMO, if I remember correctly, were used on the 5G 5G technology. So technically this is also applicable in on Earth as well. So if they, for whatever reason, JAXA maybe already figure out something to make our Earth's ground communication way more efficient than usual, maybe they will also going to try to commercialize this under another commercial arm. Maybe just like how ISRO nowadays they have their own commercial arm. They call this NSIL, the New Space India Limited. That one is the ISRO's commercial arm, just to commercially market it out to the customers, to the outside world, outside the bubble, so to speak. Okay, and yeah, this one mission overview to demonstrate and evaluate the MIMO technology, improve the communication frequency utilization, low orbit satellites. If I remember correctly, this 900 megahertz band satellite, if I remember correctly, this one technically you need a license if you try to do this commercially, or maybe for your own personal usage. You technically need to get the license. But in the case of, let's say, where I'm living right now, around we have to specifically ask the MCMC, the Malaysian Federal government body. That one is something to do with the multimedia communication. Yeah, multimedia communication. We have to go with them if we have to do it. But I believe also at the same time, because but also if I remember correctly, as recently, if I remember, technically we also have to deal with the SMA, the Sarawak Multimedia Authority also as well. They are basically like the imagine like what I said, like if federal government have the MCMC, we also have SMA. So basically, to speak, it's like the Sarawak's MCMC version, the local state government here as well. So we have to deal with these two entities. If you want to use this specific frequency band spectrum here. So apparently this Liomi, even though I cannot say too much here, but yeah, because I think I would like to rest a little bit of my mouth here. But the complete set of the mass itself is 3.7 kilograms. Okay. Okay. Because I'm a little bit pedantic with this side, upper side there. Okay. And the implementation manager, of course, it's going to be the entity corporation from Mr. Fumihiro Yamashita, apparently. With co-implementers, of course, going to be JAXA. Entity stands for Nippon Telegraph's telecommunication, if I remember correctly, what entity stands for. And the Gemini, this one, of course, commercial GPU for them to test out the consumer GPU to do some ultra high speed calculations. Can be such as to calculate the to enable basically high speed signal processing, such as AI processing, just to identify what that will be complemented together with the Iris, if I remember correctly. Iris and also what is it? Iris, Liomi, and also CFCam, basically to do some detection and also communication together, integrated inside it. And the SAR playback, SAR, if I remember correctly, SAR playback processing. SAR is technically, if I remember, stands for synthetic aperture radar, or maybe search and rescue. I don't know which either of these two. And etc. and also it's going to be whatever is it, and the implementation manager itself is the Mitsubishi Electric Corporation, by Mr. From by Mr. Asahi Chiba. Okay, the total mass would be 0.7 kilograms, aka 700 grams, and of course this one is the in-orbit demonstration of a micro-integrated propulsion system using water as a propellant. It says here, which were implemented by the Pale Blue Corporation Limited by Mr. Jun Asakawa. Okay, with the total mass of 5 kilograms. Okay, and it says here that this propulsion system will actually integrate two things inside here, an ion thruster that will use water as a propellant, and also a resistor jet thruster. Yes, I was correct on this one, even though I was wrong on the pulse thruster one. That one is for plasma, but my speculation is actually really correct. The resistor jet, if I remember correctly, how the resistor jet actually works is that you heat up this metal coil that looks like a spring. Okay, looks like spring, but something like I don't know how do I visualize this without hand tracking Nebel here, because I wish I can do that, but that one it will be reserved for the future when I have new laptops. Hopefully this is good. That one will be okay for me to show. Okay, usually you will heat up this metal coil to how certain degrees, until, if I remember, until it got so hot that it looks like a melting, like not really melting, it's like overexpanded, very very hot red iron color, something like that. And then after that you will flow out all of this water, but in this case they are going to flow out all of this water. Just mix these two together, and on the combustion chamber it will produce, guess what, it will produce a very very high speed, high velocity steam molecules that will be pushed out from the combustion chamber to exiting to the nozzle, to the nozzle itself. So that's basically how it works. and surprisingly, actually, resistor jet is pretty simple to build. I mean, when I think about this properly, this is actually the smartest solution. Okay, I need to admit, this is the best, smartest solution implemented so far. So well done. They actually figure out how to make it works, instead of just using cold gas, because cold gas has low specific impulse. Might as well just switch with what might as well you just heat up those resistor jet coil up. Just put water with it, superheat up, it becomes steam, get out, and it becomes steam. And the propulsion will only be water steam there. Congrats. That's actually the best solution I actually seen so far. The best solution. It doesn't need to do some electrolysis, whatever is it. So yeah. And momentarily we are also going to see the ignition of the QV. Okay, upper stage. We are going with this after that. Okay. Okay, and T-minus 10 seconds. And we are getting ready for the ignition of the QV. Getting ready ignition. Getting ready on my mark. And QV upper stage has already ignited by now. And the ground acquisition signal should have already been picked up. And it will ignite until T plus 53 minutes and 44 seconds, I believe. Yeah, 53 seconds 53 minutes and 54 seconds. Sorry, correction. We will see. We will see afterward. We are going to go live shortly with the with the payload deployment there. Okay, and we shall be get ready as well. Oh, how do I do this? It took a bit while. Okay,
Welcome back to our
but
77th
never mind.
Electron launch. It's almost time to raise and shine for JAXA's RAISE-4
Yeah,
spacecraft.
raise and
We're just
shine.
moments away now from the final few events of today's mission. We started out with a beautiful clean liftoff from Launch Complex 1 about 50 minutes ago at 3:09 UTC.
Today's mission was very nominal. That's just how we liked it. We made our way through max Q, main engine cutoff, stage separation, second stage startup, and separation of the kick stage to the staging orbit that we're currently in before the mission's payload deployment. Now, to move from an elliptical orbit into a circular one for today's mission, the kick stage's propulsion system lit up its Curie engine to position the platform correctly
Okay,
at a
get
540
ready.
kilometer altitude. Engine
30
startup
seconds
just a few
before
moments
the
ago,
Curie
with engine burn time expected
upper
to last
stage
around 2 minutes or so.
cutoff.
So Curie engine cutoff is scheduled to take place just before the T plus 54 minute
20
mark,
seconds.
So let's hand it over to mission control.
Ten seconds to go, and on my mark for the Curie upper stage cutoff, engine cutoff. Okay, should be marked by now. Let's listen in for the confirmation. Okay, should be in anytime. Okay, by now already cut off and getting ready for the JAXA's RAISE-4 satellite separation. Okay, payload deployment has already confirmed, and normal orbital insertion. So we have already confirmed. And getting ready, we will see on the animation
Great confirmation
sequence
from
here.
Mission Control, and congratulations to JAXA and the team behind RAISE-4. Your spacecraft is now successfully deployed to orbit and ready to begin its mission. And that completes our Electron launch for JAXA and the first of 2 missions.
Yeah, so here's the animation here.
Demonstration program.
So already
It's been an
done.
honor to be part of this mission for JAXA, and we're excited to see RAISE-4 begin its technology demonstrations.
Yeah, so the part 1 of the RAISE-4 mission has already been commenced right now, already separated and pending for the for the ground control.
With the next 8 spacecraft in program. These
Okay.
include educational small sats, an ocean monitoring satellite, a demonstration satellite for ultra-small multispectral cameras, and a deployable antenna that can be packed tightly using origami folding techniques and unfurled up to 25 times its size. We definitely can't wait to see that one launch on Electron early next year.
Now, before then, though, we have another couple missions to fly before the year's out.
All
So
right.
keep an eye on our website and social media
Yeah, just in
channels
case.
for the details of those launches in the last weeks of December.
Until then, though, thank you so much for tuning into the broadcast today. We'll see you back here very soon. This is Rocket Lab Mission Control, signing off.
Alright, so Rocket Lab has already signing off, and here's the launchpad view of the Launch Complex 1B located in Mahia Peninsula in New Zealand. Here you can see. And that's all. Thanks for watching today's live coverage by the Rocket Labs, and of course you can go visit their Twitter, their X account on x.com or maybe twitter.com/rocketlab. Yeah, because I refuse to not even call it Twitter anyways. So so also at the same times, let's go open the music, and I will try cover the rest of this. We are not going to be that long here. Okay, Oh, and this one here, let's go with the second part of what I'm talking here before we finally end this stream. Okay, this one is the number 4, the pulse plasma thruster for small satellite, aka known as the TDS-PPT. Okay, so this one is in orbit demonstration and also in orbit demonstration and evaluation of a pulse plasma thruster PPT for small satellites, and they are going to test this in a low power, compact, and inexpensive solution for the for small and micro satellites there. That's why they are going to use this, and I think. And I believe that maybe because they said this is for pulse plasma thruster, I believe they might utilize the Earth's ionosphere and also the solar photons, how do I say, surroundings for the capability for the pulse plasma thruster one here. And I need to say, I also like this idea. I mean, in this case, maybe this is what we call, if I remember, this is sort of like the air breathing propulsion also at the same time. This is also a very emerging interest in this space application. I mean, like, sure, we have air breathing propulsion specifically for our for airplane around the world, aeroplane, whatever is it. But the problem is that most of this confined on a very breathable living of our Earth's atmosphere. So what they are doing is that they are pushing this up, going it to this space instead. They are using this in a low power solution manner, and of course it's not going to be not going to be meaningful with the thruster, with the thrust amount of it, just similar to how the water propulsion system here. But it's still, for me, it's still groundbreaking. It's still the best technology you can have to put inside of your spacecraft. And technically, as long as your spacecraft is still alright, you still can communicate with it. Technically, the source of this thruster here is practically unlimited at this point. What you're doing is you're just harnessing around what the Earth's atmosphere provides for you, and also what the solar flare photons also provide to you. You just use it, don't waste the waste. You just capitalize this upside one here. So that's it. And of course, the mass itself going to be 1.4 kilograms. Okay, the proposing organization and also the implementation manager, it's going to be Takahashi Electric Works Corporation Limited by Mr. Toru Takahashi. So co-implementers would be the University of Yamanashi. So that's that. And okay, we have 8 left. Okay, I'm not going to be that long. So this one is the diesel, the membrane deployed deorbit mechanism here. They are going to demonstrate this for microsatellites, and the proposing organization and of course the implementation manager will be the Excel Space Corporation Limited by Mr. Minoru Kurata here, that represents this agency here, this company. Okay, and what they are going to use it, they're going to use it to accelerate the orbit of the satellites, and especially after the operational life is over, essentially to ensure that the Earth's Earth's orbit not going to be littered down with a lot of satellite that could essentially be very, very bad for Earth in the future, especially if you know about the Kessler syndrome, something like that. Even if you heard it recently right now about the Shenzhou 2020 spacecraft was stricken by the orbital debris, and also even other one like Iridium satellite being, how do I say, colliding together in colliding with the old Soviet Cosmos satellite, Spice satellite, something like that, and also something else more and more, and also sometimes even let's say, for example, the satellites or even the rockets upper stage suddenly just broke down and just explode to the point of, well, it scatters the debris. So that's where the actual worries would be. So that's why this technology is very important, especially if it's already operational life, or at least if they cannot maintain it anymore. So this is what the diesel is actually for, to demonstrate it. And the mass will be 1.9 kilograms. Okay, and co-implementers for this mission will be the Sakase EdTech Corporation Limited here. And the number 6 here is the Helios R. Okay, this one for the lightweight membrane deployable structure for power generation, and also for antenna functions in there. And there are also, it says, for Society 5.0. Okay, I believe if it says like for Society 5.0, I'm not 100% sure what does it means with Society 5.0. Is this something to do with 5G, like it says here, or could be mentioned something to do with the Industrial Revolution 5.0? Could also be at the same time. Could also be these two, both are correct. Maybe that's what it actually refers to. Okay, and it says here that and of course the implementing organization and also the implementation manager will be from the company that's also become co-implementers for the diesel, Sakase EdTech Corporation Limited. This one by VOG Sakai. Okay, this one for the high performance, low cost, small satellites communication for the high power, high capacity 5G communications / high resolution observations using interferometers. So apparently they are also going to use this 5G spectrum to also do some Earth observation mapping as well. Okay, if my understanding is correct. I mean, this is also feasible as well, because you need to remember there's also study using the radio technology to map something. So and especially with the sonar technology, so not impossible, it can be also done using the equipment, especially the off the shelf equipment that you and I can buy as a consumer. Although I can say in recent trend, I can say due to the AI industry literally just serve up everything else for themselves, tech shortages, especially the chip shortages, will be pretty inevitable for few years to come. Yeah, unfortunately, even the prices of the DDR5, DDR4 RAMs is literally just goes up. Even the SSD itself, even the hard drive. So I say, yeah, so for a few years it's going to be painful for us, unless you happen to be able to do some maybe dumpster diving, just to find any good storage, maybe even RAM. But I hope you don't go that kind of level. Maybe the best you can do, if there's option you can buy it cheap, maybe you might as well just go with that and repurpose it, fully clean up all of that things to do whatever you need to do, especially if you're in the robotics, in the engineering side of things, or maybe even computer science like me, student like me. You might also need that. So just be prepared in case that happens. But anyways, I'm not here to spread any kind of alarmist whatever is it. It's just that's the reality. Okay. But even then, stay calm. If you have some funds, do it as soon as possible. Don't just wait until it goes 5 times or even 6 times. I mean, like for all of us that actually experienced this back around the COVID shortages, tech shortages in general, COVID shortages, you don't really want to figure that out. You better don't see it. That one is really painful, seriously painful era for me, for you, and some that also successfully going around that kind of painful era, you know. And yeah, the speaker of which, let's go back here. The mass itself will for this Helios R will be the 2.9 kilograms. Okay, and the co-implementers obviously going to be JAXA, Tokyo University of Science, and also National Defense Academy. So apparently with this Helios R, there's also going to be sort of dual purpose usage at this point. So half civilian and also half military side, because apparently National Defense Academy involved here, so they have this interest, these two as well. But yeah, but the rest of it, well, this is the only information we know. We can only just infer what this is all about. Okay, and the CF-cam, obviously radiation resistant Earth observation color camera. So apparently this is actually pretty interesting. You can see the mirror, the lenses here, they just stack it upon together. They just, okay, that's also pretty smart idea as well. Even though you can package this pretty small, but this is seriously genius. Even though I've already seen this setup multiple times, it's still genius. Especially if you really need MacGyver's solution, you want to put it inside. You want to build your own Earth observation satellite. You can technically just use whatever good, I don't know, maybe even any good small GoPro camera or literal equivalent to this. Sorry, no. You can use that, just stack it with these lenses, provided that you also already experimented with these lenses, but better you calculate it first to know which one is what certain lambda, whatever is it, just to make sure it's not going to be blurry. Yeah, this one is also technically very smart idea. You can just stack it, and you've already have your own Earth observation satellite there, if you really desire. Technically, you can build one. Nothing will stop you. The information is already out there. Okay. Yeah. So literally, you can even buy any of this cheap already used one, and you still can turn this into a pretty capable Earth observation satellite as well. Even though it's basic, rudimentary, but yeah, well. And yeah, of course, this is going to be a CMOS camera. What else do you want to know? And the implementation organization and also the implementation manager will be the Mark Corporation Limited. Mark Corporation Limited. What? How? The translation doesn't make any sense, but let's try to do this. Mark Corporation Limited. Yeah. By Mr. Akatsuka Takefumi, okay? And they are also going to use this for the demonstration for the future satellites as well, if they can make this good. And the total mass itself will be 2.5 kilograms, okay? Oh, so apparently SOC, that one is the MPU, multi-purpose unit, or maybe let's just say for familiar term, we're just going to call this APU, whatever is it, in accelerator processing unit, whatever you want to call this. Anything works. MPU, APU. Okay, this one is number 8, the onboard AI object detector using SOC chip actually. Okay, this one is IRIS, AIRIS. Okay, this one is for the detection and to test out the detection of the object using the onboard AI technology, or aka much better terminology would be the machine learning one. specifically if I have to be very pedantic, it will be machine learning stuff. Okay, this one, the implementing organization and also the implementing manager would be the Mitsubishi Heavy Industry Limited by Mr. Kazunori Masukawa, I believe Masukawa. Yeah, Mr. Kazunori Masukawa. So this one is the mission overview is that to verify the space environment durability of the next generation space MPU using the SOI SOC4. Okay, that's not very consistent. But whatever, we just call it SOI SOC4 moving forward. Okay, where they're going to demonstrate in orbit the entire cycle of detecting ships. Oh, they're going to detect ships in orbit using it, and also onboard AI chip, or also known as the NPU, the neural processing unit. Okay, which will downlink only the necessary data and updating the AI of the onboard AI chip through relearning, or aka, if I remember, to machine learning using the acquired data, is if possible. Yeah, it's possible, or if possible. That's why I said this is technically can be called as the machine learning as well. I prefer to call it machine learning. Everyone already used the AI word to death. Yeah. Even I could have already vomit by now if I have to mention this many times, I will vomit it. So that's why I try to use this sparingly. Okay, I don't want to use that word, that two words starting from A. You know, is it? Let's just say you know who word. just so I'm not vomiting myself out trying to mention this, because why not? Everyone wants to pump their stock for whatever ridiculous reason. But whatever is it, I have nothing bad with them. Okay, so this is a very important note. I don't have anything bad to them. It's just that the term is already being used to death at this point. I'm tired. Even as a computer science student, I'm very tired. Okay, and yeah, there's going to be three payloads which integrate into one as the Iris. This one, total mass for the AMDP will be 770 grams. For the SAM-B, ACAM-B will be 200 gram, and also ACAM will be 623 grams. And now I'm going to commit mathematical attempt here, if I have to try to plus everything else here. Okay, 200 plus 623, 823 plus 770 grams, I believe 880. Okay, sorry, 800. Okay, my brain doesn't work right now. Okay, 15. Okay, 15. Okay, 1593 grams, aka almost 2 kilograms, around 1.593 kilograms. Yeah, so here is it. That's my attempt trying to calculate without using calculator, using solely my brain. Okay, so that's it. That's what you need to know. This size itself, well, it's around ranging from around 60 millimeters to whatever, 300 millimeters, 900, whatever is it. But not super duper important for you to 100% know this. Sometimes even thousands, they here if unfolded. Okay, 2000 plus, almost around 2300 millimeters. Yeah, because we are not going to waste our time. Okay, and I guess, yeah, that's all, everybody. Thank you so much for watching. Okay, thank you so much. I really appreciate it. You guys really rocks. Okay, you guys actually really bothered to watch my stream, even though you guys can watch somewhere else, but you still want to tune in. I'm very appreciative. You guys rocks. Okay, you guys are awesome. And I guess yeah, and I guess that's it, guys. Until until we meet on next stream again around. I'll see you on the Monday. It's going to be stream. Let me try go with the next spaceflight.com. That one is the NASA space flights um, rocket tracking website, rocket launch tracking website there, just for us to see. Okay, so it should be something like here. Okay, I don't know, this one a little bit hard to try to stream. Starlink, mostly I don't care anymore. Too semi, you're going to get bored. I mean, you can actually watch other streams. I'm not friendly with that. You can try watch something else, especially with Space Affair, with Raw Space. Yeah, that one is also, how do I consider this as the friends of this channel. So go and watch that instead if you don't mind watching other watching Starlink launches over and over. Okay, so I'm going to see you. Okay, apparently they already moved the Proton M launches to, yeah, what happened? They already moved it to next year, January 2026. I don't know if I could even stream this, let alone Gaganyaan G1. Okay, for the Flight 2 mission. Wow. Okay, there's also another updated mission for the Spectrum rocket by the ISAR Aerospace. Wow. Can I go stream that? I'm not sure, because by this time I'm not sure what's happened by then. And yeah, unless they actually goes around, I don't know whatever is it. Oh, so apparently also there's already updated the Kairos rocket. Even though unfortunately it has like 2 failed launches, but I hope third time's a charm. That's what's my hope. Okay, I want to see this rocket to be very successful, because guess what? It's going to be launched on the spaceport Key. Okay, that one is also pretty interesting. Around the Wakayama prefecture. So pretty interesting. I want to see that launch. If that launch actually is successful, wow, we have another launch place to go. And also the same can be said with the Zero rocket by the Interstellar Space Technologies IST, or we can call it Interstellar 2 at the same time. I'm also interested to see that, because that launch, if it's successful, it will mark the first launch orbital launch debut from Hokkaido as well, from the Hokkaido region of Japan. This one would be from the Wakayama prefecture. Wow, I hope it will be successful. I want to see new rockets as well to be successful. I want to see this successful as well, because this one is a crewed mission going to be fly by around the moon. Okay, Blue Moon Pathfinder Mission 1. I don't know if I can stream, but even if I cannot, at least I'm still very satisfied with how do I stream back then for the NASA Escapade mission, and also for the Viasat Invention communication demonstration mission. Yeah, I'm actually still pretty happy, even if I cannot stream this one, because, well, home life, I couldn't say too much. It's just not the best. But also another one, I don't know if I can stream that. Okay, Michibiki 7. I think around this time I might not be able to stream. Yeah, around probably up until almost the end of February. I don't know. Hopefully I can stream this one, because this looks pretty close to what I can try to stream around that time. I hope I can stream this. This is interesting. Okay, STP-S29A. No guarantee if they will stream this. But even if they don't, maybe I can try use the national parks camera view. That's also technically should be working. because why not? That's one of the another rare moment where I want to stream it because this rocket itself, this Minotaur 4, this one is a pretty rare rocket to launch. Okay, I don't know. Hopefully they will stream that too, because by how do I say, by their tradition, by looking back on the historical side, even 10 plus years ago, usually they will stream Minotaur rocket launches, but for whatever unknown reason they did not stream the other launches of the NRL, something like that. Yeah, I don't know, it's pretty sad, but I hope they will stream this one. Okay, sad. USSF 57. Yeah, I hope they will. I hope when ESLV Mark II actually launch for the EOS-05 satellite, I hope it will be by the time I'll be able to be back again, because I'm seriously want to stream this. And also the same to be said with this one, EOS-91 and other satellite. I don't know if I can, but for this Soyuz 2.1B Fregat M, this one from Vostochny Cosmodrome, around the far east of Russia, around the Siberia area. I don't know if I can even stream that. Yeah, I don't know, if assuming if they're even going to stream, but if they don't, well, whatever. And S37, I don't know if I even want to stream this, because how I say, I don't know, I'm pretty mixed with this one. Should I stream this? Should I not? Or if I could even stream this, I'm not sure. But Michibiki 5 looks like I can stream this on 10 a.m. I believe I can stream Michibiki 5. And also at the same time, the Galileo FOC. This one, I believe I can stream this too. Or maybe I don't. I'm not sure. Galileo one, this one, not really 100% sure, unless they delayed this to the next day, to the Thursday, or even Friday. And also STP-S30, this one here. If I'm not, if I remember correctly, I should be able to stream this one. I should be able. But for this Spaceward mission, they will launch the 100 Nano one. This one, from what I actually read the latest on Twitter, on X, they said it's on the way. They're still going on the way. So good luck, because it's also going to mark the orbital the commercial orbital flight debut, and also going to mark around 22 years, around, not 22 years, it's around, how many years is it, 98, it's going to mark around almost 26 years since the last launch of the VLS-V02 flight. Yeah, the V03, unfortunately, it exploded on the launch pad and literally kills everyone in the around the launch pad vicinity area. So unfortunately, I'm very sorry to even say it. I mean, seriously, I'm very sorry. I'm very sorry when I actually think about that stuff. Yeah, but anyways, also the Bluebird Block 2 FN1. Can I try that one too? Let me see from my calendar first. Let me try see. It should be, yeah, it should be around Sunday, like a week from now. I also can try stream that. Okay, I can try stream around 21 on the Sunday, 12 p.m. Yeah, and also you want to know why? Because I because I personally like the rockets itself. It's basically, how do I say, the modern spiritual successor to Titan to Titan 3/4 rockets. It's basically the spiritual successor of it. So that's why I'm also going to be very hyped looking this rocket. It's like, imagine if this is Titan rocket, but if it's significantly much more cheaper than the previous Titan mission, and also if they are able to get rid most of the inefficiency usually usually the hallmark of the Titan program itself. So yeah, I wish this also good luck, because this is my personal favorite rocket as well. I love this rocket. I also love PSLV rockets here. Okay. And yeah, and also I need to say I also love Electron rocket here. Soyuz, I can say technically I also love this rocket, and also its derivatives as well. And even you want to know something, I also like the Firefly Alpha rockets here. I love the Alpha rockets. If I want to say about the Angara rockets here, it looks a little bit tacky, but still okay, I guess. Okay, I still like it. Sort of. Basically, how do I say it? This one is intended to replace the Soyuz, but if it still has that Soyuz DNA, just minus that Korolev's or Korolyov's cross. That's all. That's basically it. Okay. And also what? And yes, also I love Ariane 6 rockets here, and Hanbit Nano looking pretty sleeky rockets. At least it's not entirely fully black colored. So yeah, I mean like this is not me saying in a bad way. The black color is still good, but it looks dull. And also the same too as well. If it's too white, it also can be dull. But this one, I can say it has some kind of good striking balance between having a good back stripe and also white color with the black marking that indicates whatever is it. Also all right. And also, you want to know something? I also like this #3 rocket family. I also like this, and also the #2 rocket families. Okay, looks pretty good. This is what, how do I say, #3 is basically like a full fat version of the #2 rockets. Yeah, so that's why it's basically just reminds me of that bygone era. But yeah, I hope also that JAXA will successfully go able to launch the #3, the NOS SRB solid rocket boosters with 3 core stage engines there. I also hope that one is successful, because if it's successful, it will mark possibly the first time in JAXA history where they are able to successfully launch a liquid field orbital rocket without any of these SRB assistance in some sense. So that's why I hope it's also successful. Okay. And yeah, and also, you know what? Even I also like Atlas 5 rocket here. Atlas 5 rocket family as well. I also like this. Okay. How do I call this? This looks like a little bit like, how do I mention this? This looks like mini Titan rockets. Mini Titan Titan rockets, but quite modernized, you know, just minus that the big SRB, and also minus that SRB on the ground ignition before the core stage. That's all. That's what I'm going to say. But yeah, I have too much opinion to say here, and I'm not going to waste too much time. So yeah, everybody, thank you so much for watching, and thank you for sticking around. This launch is actually pretty successful, and I'm really enjoy talking around with you guys, and also myself talking alone just talking alone, just facing around this laptop, facing around this microphone that I'm using right now, this HyperX Solocast too. Yeah, I really enjoy this. Thank you to my sister to for uh, for for the for the gift. I really appreciate it. So so this is my trademark for ending this stream. Okay, so I'm going to say it. So thank you so much everybody for watching these race 4 missions. Launch launch on boarded the Electron rocket, and I'm Dennis Suguwa. You have now you just watch this 58th live stream of these rocket launches, and we're going to see soon for the 59th live stream for presumably if it's not going to cancel for the Amazon Leo, aka the also formerly known as the Project Kuiper, although I like to call it personally as both of it. I like to personally call it Project Kuiper for the LA-04 mission on board the Atlas 551 variant rockets there. So thank you so much for watching. Take care everybody and have a great weekend. Bye bye. Take care. And that's it. Nothing else to watch here. There's nothing behind the scene. It's already finished. I've already said what I want to say. So thank you so much for watching. Take care. Bye bye.